In episode 48, titled Recognize Ports, Protocols, and Software-Defined Networking, we turn protocol fluency into faster triage and safer configuration decisions that hold up under pressure. The goal is to know, almost by reflex, what a port implies about intent, what a header implies about risk, and what a policy implies about evidence. When an alert lands or a change request arrives, you should be able to picture the conversation on the wire and choose the narrowest, most defensible control that enables the business. That muscle memory is not trivia. It is the difference between meandering investigations and crisp outcomes that you can prove with logs, captures, and approvals. Common ports and services reward plain-spoken understanding. Port 80 generally signals Hypertext Transfer Protocol, while Port 443 indicates the encrypted variant, Hypertext Transfer Protocol Secure, with expectations of modern certificates and ciphers. Port 22 is Secure Shell for administration, where strong key pairs and limited source ranges are routine, and Port 53 is domain name system traffic that ought to be carefully constrained to known resolvers. On the edge, you may see email transfer on Port 25 for Simple Mail Transfer Protocol or remote desktops on 3389, each carrying clear security expectations. The point is not rote memorization. It is the habit of pairing a port with the minimal exposure that makes sense, then validating that expectation with configuration snapshots, flow records, and sampled packet captures. Application protocols come with familiar benefits and equally familiar misconfigurations. Hypertext Transfer Protocol, HTTP, and its secure form, HTTPS, carry web traffic whose safety hinges on certificate validation, strict transport security directives, and clean header handling that closes downgrade paths. Domain Name System, DNS, is deceptively simple yet prone to open resolvers, recursion where it does not belong, and over-permissive responses that leak internal design. Simple Mail Transfer Protocol, SMTP, can become an open relay or rely on weak negotiation if start to TLS is optional and unaudited. Secure Shell, SSH, shines when keys are unique and short-lived, but becomes risky when passwords linger or agent forwarding is unchecked. In every case, the fix begins by naming the intended behavior plainly and pinning configuration, monitoring, and evidence to that intent. File and remote protocols can either be workhorses or open doors, depending on how they are exposed. Server Message Block, SMB, should enforce signing, prefer modern dialects, and live behind access controls that map shares to roles rather than subnets. Network File System, NFS, exports ought to declare root squash and restrict clients explicitly, with read-only defaults unless write access is proven necessary. Remote Desktop Protocol, RDP, earns its place with network-level authentication and gateways that terminate TLS centrally, rather than exposing hosts one by one. Virtual Network Computing, VNC, is best confined to maintenance enclaves or wrapped in stronger tunnels because its native security features are thin. Safe patterns rely on jump hosts, segmented management networks, and audit trails that link human requests to the exact systems they touched. Software-Defined Networking, SDN, reframes how we express and enforce network policy by separating concerns. The control plane becomes a centralized brain that understands intent and topology, while the data plane focuses on fast forwarding with consistent rules pushed from that brain. This decoupling means policies can reference identities, tags, and application labels instead of fragile addresses, and enforcement can happen close to workloads rather than at a few choke points. The promise is agility without chaos. You articulate what should talk to what under which conditions. The controller calculates placement, and the fabric enforces it predictably. The operational proof is clear versioned policies, controller audit logs, and flow records that match the declared intent. Overlays and encapsulations, such as Virtual Extensible Local Area Network, VXLN, or Generic Routing Encapsulation, GRE, extend networks across boundaries but complicate where you look for truth. Packets take on a new outer wrapper that rides over an underlay fabric, which means classic sensors must either understand the encapsulation or be placed where traffic is in the clear. Inspection and logging therefore migrate to virtual tap points, host agents, or service insertion nodes that see the inner headers and payloads. If the environment also uses Internet Protocol Security (IPEC) tunnels, the placement of decryption and the handling of keys become part of the visibility plan. Good designs write down exactly where policy is enforced, where packets are observable, and how those observations are retained for investigations. Adversaries exploit tunnels and covert channels to bypass filters, so teams anticipate and detect them. DNS tunneling smuggles data by encoding payloads into subdomain labels and generating a rhythm of unusual lookups. HTTPS tunnels hide generic transports inside encrypted sessions with odd beacon intervals, high entropy paths, or mismatched user agents. Even ICMP can become an exfiltration trick when firewalls treat it as harmless plumbing. Detection combines tight egress allow lists with behavioral signals like domain age, query volume per host, consistent record sizes, and length distributions that do not match normal use. When your monitoring narrates both the protocol on the surface and the shape of the conversation underneath, covert pathways become conspicuous instead of invisible. Cloud networking mirrors on-premises concepts, but names and placements differ. Security groups are stateful, instance-proximate policies that resemble a distributed host firewall defined in terms of identity and service rather than addresses. Network access control lists, NACLs, are stateless subnet-level filters that resemble classic edge ACLs and are best used to set broad outer bounds rather than fine-grained rules. Internet gateways, private gateways, and transit gateways cover external reach and hub-and-spoke patterns that, on-prem, would be implemented with border routers and core transit. Route tables direct flows as they would in a data center, and managed firewall services insert deeper inspection where needed. Flow logs at the VPC edge and per interface provide the evidence that policies behave as declared, completing the picture for detection and audit. A practical scenario makes the tightening process concrete. Suppose an internal platform exposes a wide allow any outbound rule for convenience, and inbound rules admit whole subnets to multiple ports because early development moved fast. The team first observes traffic to understand the true set of conversations, then drafts service-specific allows, such as narrowing inbound to HTTPS for the user-facing endpoint, and a single database protocol port from the application tier. Outbound becomes a curated list of resolvers, update services, and partner endpoints, each with explicit destinations and ports. Changes roll through a canary environment. Metrics watch failure rates and latencies, and fallbacks are ready if unanticipated dependencies appear. After stabilization, the new posture is promoted, and the evidence, a diff of policy, flow reductions, and incident ticket notes, shows security improved without collateral damage. To close, turn protocol knowledge and SDN capability into a standing practice that steadily reduces exposure. Begin by reviewing one production service's protocol surface and writing a current state narrative in simple sentences that pair each port and protocol with its business purpose and the minimal safe exposure. From there, plan staged refinements that convert broad source ranges into identity-tied allows and convert permissive outbound into explicit egress paths enforced by the fabric. Each stage should end with stable signals you will watch going forward, flow counters, handshake outcomes, resolver access, and with artifacts that prove intent, enforcement, and results. Over time, this cycle becomes routine, and the network evolves into a place where protocols are not only recognized, but also precisely governed by design. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.